Welcome back to the Dairy Knowledge Exchange. I'm Pat Colley, and I'm excited to share a fresh initiative we're launching in 2025 here at D&D Ingredients. Each month, we'll bring an educational webinar on this platform, spotlighting timely industry topics and featuring one of our valued partner products. Make sure to visit the D&D website regularly to explore these new learning opportunities.
Hello, everyone. I am Dr. Bill Stone, and today I get to share with you some really interesting information about this journey we've been on at Diamond V, learning about our products more and how they really work. So today we'll be talking about how our products can work to modulate the ruminal microbiome and also to support the health and the immune system of the animal. We have what we call our original line of products. That's Diamond V XP and XPC. And then our next generation products, which include NutriTek for dairy cattle. NatureSafe is a sister product of NutriTek for the beef industry. And for calves, we have Smart Care, which is a product that's soluble in milk. And again, we'll be going on this journey, a journey through our research and what we've learned. I got to go to graduate school, veterinary school at University of Wisconsin, and graduate school at Cornell University. And one of my mentors and friends at Cornell, Dr. David Galton, we were one time talking about a research study of his, and he kind of smiled and he said, "Boy, a lot of my best ideas I get from the field." And here's an example of that. Pre-dip in dairy cows. It wasn't thought up actually at a university. Some advanced dairy producer was doing it. And was it really working? So we needed controlled research to find that out. Or how about straw and pre-fresh diets? Great work at the University of Illinois, but it was being done first in the field. So the great idea came from the field, and then the university proved it out. Well, one comment we've heard often from producers or from nutritionists is the comment, Diamond V products seem to help the cows get through forage changes and with quality issues that may occur on the top or at the end of the bunk. Okay, so Diamond V products seem to be helping my cows get through these big potential ruminal challenges. There is some work in the Western U.S. here with NatureSafe. Again, this product similar to NutriTek for the beef industry. And this was an all-natural yard, and animals had been on a control diet without NatureSafe, and then they, at another time period, they were being fed NatureSafe. And what the producer saw was that there were fewer fallouts, and here these animals were coming from Montana, than there had been when they were not receiving NatureSafe. And the fallout is when an animal has to leave that all-natural program and be treated with antibiotics. Often those fallouts were occurring because of a respiratory problem or some GI issue. So that was from Montana. These animals are coming from other states. And once again, these fallouts, 11% in the control and about 5% in NatureSafe. Again, was this from NatureSafe or was it just coincidental? We didn't know. We started NutriTek now, I think it was in 2016 about when we started with NutriTek. And we were working on accumulating health data. And this was a herd that went on NutriTek, and we're looking at the incidence of clinical mastitis in these pens that were going to be going on to our trial. So here's in October. The pen in red is the pen that's going to be the control pen, and in black is in NutriTek. Clinical mastitis are about the same at 4 and 7. November, they're 10 and 16. They start NutriTek in early December, and you can see the clinical mastitis is again similar in December. In January, it's 25 in the control and 14 in NutriTek, and in February, 26 in 4. So for overall, that level of clinical mastitis was about 3% in controls and 0.5% in NutriTek. And it's interesting, but again, we don't know if that was related to NutriTek. This is another just interesting observation. We have in red here a cohort of 44 Western U.S. dairies, and we're looking at their somatic cell count over time. And we see these seasonal changes in somatic cell count that are happening. And in blue is one herd. And in general, that blue somatic cell count is pretty much following that cohort. And here, the blue herd goes on to NutriTek, and they're right around 150,000 somatic cell count. And they kind of linger around there, and then they drop down to about 70,000. And my colleagues from out west had shared this, and I remember asking, well, you guys, what else changed on that dairy? Did they go with a new milking procedure, a new pre or post step? Did they change the environment for the cows in that herd that everything improved? And my colleagues said, no, not we can't find anything other than a NutriTek, and talk to the herd managers, and they can't think of anything either. So again, interesting, but we don't know for sure was that from NutriTek. This is another dairy now that wanted to do a little comparison of their control versus NutriTek. And they did that over a few month time period and looked at health events and about 200 animals in each of our control and NutriTek groups. You can see rumen health events about the same, mastitis here about the same, but a huge difference in lameness. 88 lame cows in the control group over this few month trial, 26 in our NutriTek group. And the biggest cause of that lameness was warts, so 68 versus 16. Again, this was shared, and I'm skeptical of these things. And what I remember just saying, well, was there a difference in the environment? Any a wetter environment, for example, in those control cows, wetness and more manure on cows' feet can lead to more warts. So was any difference there? When, well, geez, not that we saw or that we were aware of. So again, interesting. Was NutriTek involved with that reduction in warts or not? We don't know. So these effects from the Diamond V products or random chance. And how can we prove this? Whenever we see something like this on a farm, it is really difficult to know if it was from our intervention, and here we're talking about Diamond V products, or from something else that changed on that dairy. So how can we prove this? Well, the best way we thought to really try to prove this is with different challenge models. And we're going to start out with the rumen and look at some rumen challenge models. And then we'll look at challenge models for we'll touch on all three of these, the udder, the feet, and lungs here. So the first challenge model, this came from Dr. Mike Allen's group at Michigan State. And Dr. Allen had heard those same comments I shared, where it seems like these cows on Diamond V are handling these big diet changes better than other herds not on the product. So how can we look at that? And the way we decided to do it was, let's take our cows and let's just have them be happily eating their TMRs, and they've been on this diet for actually 25 days. And then we're going to be like a producer that ran out of cornmeal and decided the next day, I'm going to have that bag of high moisture shell corn opened up that's been fermented for a year. It's finely ground. It's very ruminally available, and there's no adjustment. They're just switched overnight. And we're going to see what happens to those cows with that change when they're either on the control diet or when they're being supplemented with Diamond V XP. And again, this is trying to simulate feeding errors that might happen or big forage or other carbohydrate changes that could occur on dairy or even big feed bunk management type issues. What happened was in the control group, when that switch was made, their milk fat went from 3.34 to 3.04. Now, this is 2009, not our milk fat levels of today, but 2009, 3.34, they dropped to 3.04. When those cows were on XP, their milk fat remained exactly at 3.32. No change in milk fat. Interestingly, with fat-corrected milk, on the control group, it went down from 84.7 to 81.4. And when they were on XP, went up about 4.5 pounds from 83.6 to 88 pounds. So again, the Diamond V cows actually went up in milk and they maintained their exact same milk fat with this big carbohydrate challenge. Well, we wanted to dig into that further. And this was a research study in Western Canada with beef feedlot animals. And it's going to be done in a Latin square. So every animal is going to go through this same treatment here. And again, because it's a feedlot, it's Western Canada, that means barley. We got 10% barley silage and 87% barley grain. Feedlot diet. It's still about 30% NDF, but it's 53% starch. And it's barley again, so it's more rapidly available ruminal starch. And it's going to be a challenge for these animals ruminally. But this is, again, a more typical Western Canadian feedlot diet. Now, it's a Latin square. What that means is that every animal is going to go through the same treatment. And then after everyone's gone through it, these results are going to be summarized. And this is looking at ruminal pH, and in black is when they're on the control diet. And you can see that pH drops down to about 5.3 after this initial meal. So they're fed, it's like 6.5. They're eating that great barley-based diet. The rumen microbes are saying this is fantastic, and they're doing all this fermentation, and pH is dropping down to 5.3 and then recovering. When they're on Thailand and Rumensin, we see a slight improvement in that pH, dropping down to about a 5.4. But interestingly, when they're on only NatureSafe, and this again is all animals going through this treatment, they only drop down to about a 5.7. A real attenuation in that drop in ruminal pH. And of course, cellulolytic bacteria, the bacteria that break down fiber, they want higher ruminal pH. They really want it above 6.2. Really, the higher the better. But as that pH is dropping, they can't be fermenting NDF like we would want them to. And that's what we're seeing. Here's ruminal NDF digestibility, about 40% when the animal's on the control or the Thailand Rumensin treatments, 53% NDF digestibility when they're on NatureSafe. When they looked at total tract, because there's fermentation in the hindgut as well, everybody went up, but still that difference remained at about an 11-point increase when animals were on the NatureSafe treatment. Interesting. So a real maintenance of that ruminal pH and a dramatic difference in it, which really led to this increase in NDF digestibility. So we dug into that more. What's happening? How is that microbiome behaving differently when animals are on our DimeV products? And this study was done with 32 animals. We've got 4 groups, 8 animals in the group. It's going to go from 4 weeks pre-freshening into 12 weeks post-calving, and they're going to get top dressed. Everyone's fed the same diet, and they're top dressed with 140 grams of corn or some corn and a regular dose of XVC, or our regular recommended dose of NutriTek, 19 grams, or a double dose of NutriTek. They're going to go through calving and the transition that happens there, the challenges that happen there as they go through that. But then also, these cows are going to get exposed to a subacute rumen acidosis challenge on weeks 5 and 7, where 20% of their TMR will be removed and replaced with a wheat and barley pellet for an entire week. And rumen samples will be taken, and we'll see what happens. Well, this is looking at animals that were on the XVC treatment as they went through the whole course of this study here. And it's looking at the relative abundance of the 2 main bacterial phyla in the rumen, Firmicutes and Bacteroidetes. Okay? And we're going to follow these control animals. And we're looking at this relative abundance, and here they are, they're freshening. We see this downshift, and then they recover as they get on the lactating diet. Here's this first SARA challenge. There's a big decrease, a recovery, another big decrease. And we see essentially the same thing happening with Bacteroides, just going in the other direction. But we see these pretty significant, substantial changes as these either freshening events or the SARA challenges are happening. We see a much more stable abundance of these major bacterial phyla when they're on XPC. So these challenges are happening, but the microbiome is being stabilized when they're on both our XPC and our NutriTek products. The robustness, the capacity of the microbiome to resist change was obviously increased when they're on XPC. And the resilience, the capacity and time it takes for the microbiome to return to equilibrium, well, it hardly left equilibrium when they're on XPC there, so it was much improved in that manner. Okay, so this real interesting effect on the microbiome, really stabilizing it, really making it so that these potential changes that can disrupt it and lead to things like a drop in ruminal pH or a big growth of other species of bacteria within the microbiome are not occurring. So that was the rumen. With the udder, and we saw these signs. Were we having an effect on mastitis or not? Didn't know. So how can we do it? Well, went to the University of Illinois, where Dr. Juan Lohr's group had a strep uterus mastitis challenge and took 20 cows where half were fed NutriTek of these dairy cows, lactating dairy cows, half were fed NutriTek, half were fed same TMR, just control diet without NutriTek. They're fed that for 45 days, and then they get a strep uterus challenge in their right rear quarter. And they're followed along. The immune response is looked at in terms of looking at somatic cell count. How they came through this whole infection, looking at milk yield was evaluated. And really, most importantly here, mammary and liver biopsies taken to look at RNA sequencing, to use the RNA sequencing to look at genes that were up and down regulated in the control or NutriTek groups. And here are these cows now. And this is the last milking before the challenge. This is their linear score. Remember, a 4 is 200,000, 3 is 100, 2 is 50. So they're like 40,000 somatic cell count. Really good, clean cows. They get challenged, and it takes a few hours. They get milked. A few hours later, they get challenged. The next milking, we don't see any effect on somatic cell count yet, or the milking after that. Finally, on the third milking, this control group, inflammation is occurring. Somatic cells are really going up. And this next milking, they're about 1.1 million versus 179,000 in NutriTek. And the IACOC protocol was after 30 hours, everyone was treated with antibiotics, and that's what was done. In addition to, remember, these biopsies were taken too of mammary and liver tissue to look at the genes. So that's what was observed with somatic cell count. This marked difference in somatic cell count in our NutriTek versus control groups. Interestingly, there's also a big difference in how they handled this infection. This is looking at production levels coming right up to the time of the challenge. And obviously, both groups are making essentially the exact same amount of milk at about, let's say, 35 kilos. They get challenged. They've got mastitis. They're getting biopsied. There's this big drop in production. And then this recovery starts to happen. As the recovery goes on over several days, where it finally ends up, let's say here after about 10 days, is our NutriTek cows are making the same amount of milk. Their production was not damaged by this mastitic event, while our control cows are down about 10 to 12 pounds in milk from where they had been before that challenge. Okay, so remember, these samples are taken for RNA sequencing. These genes were evaluated, and we're going to come back to that in a review paper done by Dr. McGill's group as we look at the overall effects of our products. Okay, so that was the udder. What about the lungs? Again, we got these signs that maybe we're helping out with the respiratory system as well. How can we check that out? Well, Dr. Jody McGill's group at Iowa State has a BRSV challenge model, and that's what we use to really evaluate this potential health improvement. And here, Holstein Angus calves were obtained from commercial dairies, and they're brought into Iowa State. They're just little young calves, 1 to 2 days old. They go on a good base milk replacer plus calf starter. That's our control group. Or they're going to get that same milk replacer and starter supplemented with 1 gram per day of Smart Care in the milk replacer or NutriTek top dressed at 5 grams per day on the starter. And that's going to happen for 21 days. And then the nebulizer comes in. And these calves can't avoid the BRSV, which is going to be put into this nebulizer. They're going to breathe in, and all the calves are going to get BRSV. They're going to be followed for the next 10 days. They're going to be scored for clinical disease. And then finally, after 10 days, they're going to be humanely euthanized and necropsied and more samples collected. Following this infection, look at clinical disease, virus shedding, lung viral load, cortisol, and we'll be looking at gross lung pathology here as well. So here's looking at our clinical disease scores. Again, they've gone on a nebulizer. They're being observed every day here. These clinical disease scores, we're looking at body temperature, respiratory effort, respiratory rate, listening to the lungs. Are those calves coughing? Is there a nasal ocular discharge? And what's the position of their ears? So putting that all into a modified Sheila-McGurk calf scoring system, putting that into a scoring system, scoring these calves. And you can see for the first several days post-infection, there's not any difference. But here now, day 6, 7, 8, and 9, there's a significant difference where the control animals have an increase in clinical disease scores compared to these animals on our Diamond V treatments. So that's interesting. The calves, as I mentioned, are necropsied, and the lungs are removed, and now they're scored based on how much pathology there is, gross pathology there is to these lungs. And these are the control calves. Here's one entire lung lobe that is totally consolidated. Another calf, we see portions of lung lobes or whole lung lobe. We see lots of damage in these calves. Control, here's our Diamond V treatment. And here's a perfect lung. Here's just one with a little small amount of consolidation. And this lung looks great too, maybe a tiny bit there, but markedly different. So did we cherry pick the results? No. Here's all the calves. First thing to note, there's 10 calves here and there's 12 here because 2 of the control calves didn't survive. But now, how much of the lung is involved in the pathology score? Well, here's 0 amount involved. We've got 5 animals on our Diamond V treatment versus 1 in the control. 1 to 5% of the lung involved, 5 versus 3. And you can see how many more of the control animals have a lot of lung involved. So there's much less lung damage in these calves after the challenge with BRSV when they're on our Smart Care in NutriTek treatment. Very interesting. Again, we're going to come back to mechanism of action, and that's going to be our summary paper, but I just want to share all these results first. Well, digital dermatitis. Remember we saw that trial with warts, and was there anything there or not? So how can we look at this? Well, we're fortunate that a digital dermatitis expert is at the University of Wisconsin-Madison, my alma mater from veterinary school, by the way, Dr. Dorothy Dofer. So Dr. Dorothy Dofer led 2 trials looking at this potential effect of NutriTek on hoof warts, and I'm going to share one of them with you. And this trial was done in Wisconsin, involved again with the university at one of the research sites. They obtained actually about 140 animals. 120 were eligible for the study of these 6 to 7 month old Holstein steers acquired from 3 commercial beef farms. They were fed a TMR with either the control or NutriTek at 12 grams per head per day for 6 weeks before the challenge is going to happen. So 6 weeks they're on control and NutriTek. Then a subset of these animals, so we've got 60 and 60, we're going to take 25 from each group, and they're moved to the experimental barn for the challenge work. What that challenge work involves is that with digital dermatitis, part of it is the environment in a sloppy, wet environment, and basically doing some damage to that skin so that the treponema organism can get in there and infect the animal. So to mimic that environment, the researchers started out and they cleaned these feet up, they wrapped them with cotton, and they started getting that cotton wet. And here you see um, some elasticon being put on. There's plastic being put on to hold all this moisture in, and they're being wrapped up more and vet wrap and duct tape and finally put in a plastic boot. So this is all this wet environment. It's going to be held inside this wetness with all this plastic, and the skin is going to be macerated over this 8-day time period when this is happening. Of course, the animals are being followed to make sure no animals is getting too lame or too sore or any issue like that. But the skin is definitely going to be challenged when it's in this moist environment. This is a closer up picture of this boot. It's this adapted equine rubber boot, again, to really keep that moisture in there so that we have this skin that is primed for a DD infection. Now, the way these lesions for digital dermatitis work, it's kind of a screwy scoring system, let's just say that. But these M2 and M2Ps are the bad ones. So they are the real active lesions that are shedding a lot of treponema. And then as these lesions hopefully are resolving, they go from this M2 to M2P often an M4P or an M4 with hyperkeratosis, and ideally an M0, which is nothing. That's where we would like them to hopefully remain, never become a hoof-forked animal or go back to ideally. But again, the M2 and M2P are the real proliferative ones. Well, they needed a donor source. So the researchers found 11 donor cows with these M2 lesions. These M2 lesions were excised, the cow wrapped up good, and a week later, this is how well it had healed. But unfortunately, it looks like there's some little wart, nasty remnants that are coming back. So excision is certainly not how we want to take care of hoof warts, obviously. But that's what was happened. That was done to get this whole infective active lesion. That was taken back to the lab. It's cut up, ground up, and mixed with some saline. So we have to have this whole concoction now that's going to be the digital dermatitis infectious broth. And they also made these silicone wafers, which were a round disc that had a really neat little concave depression on one side of them. And I'll show you how that was used then. So again, those steers have been wrapped up for a full week. Now it's the 8th day. They take that wrap off, clip the hair, dry the feet up off really good, and then glue those little discs on to 4 different spots here, right above the bulb of the heel and right below the dew claw. So 4 spots they're glued on. And then a little bit of that broth was taken and injected through this silicone disc into that depression area that I described. So not into the skin at all. It's on top of the skin in this area that's sealed away from oxygen. Only the air that's in that little reservoir is there. And this broth is put on top of this skin that's been made susceptible to an infection. A little tape put on there. And again, they're wrapped up again. They're wrapped up again and left for another week. And after a week, that is everything's taken off. And now what was there? So they looked at each of these feet after this time period and scored lesions that were present. And an M1 is a lesion that's less than 1 centimeter in size, and an M2 is a lesion that's at least 2 centimeters large. They scored all these animals, and I should mention again, everything is always done blindly here. Scored all these animals, and what they found, we got 24 control steers, 92% of them basically had M2 lesions. Of the 25 steers on NutriTek, 15 of them, or 60%, had M2 lesions. That is obviously a real reduction in the M2 lesions. Or if you're a control steer, you're 1.53 times more likely to have an M2 lesion than not. So Dr. McGill's group went through all of the research to work on summarizing both observations and then proposed mechanism of action here. So first, looking at what was observed here. When animals were on diamond beef products and they're stressed, what was observed with heat stress was primarily reduction in cortisol and these acute phase protein response, improvement in production, or at least I should say less production loss, and improvement in body condition. With SARA, there's a moderation in the ruminal pH and inflammation. When animals who feed restricted, they're able to maintain milk fat and protein. Animals going through transition, reduced inflammation, an improvement in feeding behavior, more stable intake, improvement in production and milk quality. For the areas we've really been talking about here with an infection, if it's bacterial based, like mastitis, the strep uterus we looked at, we saw a reduction in inflammation, lower somatic cell count, less reduced incidence of mastitis, and a faster recovery. With digital dermatitis, it was a slower infection progression and reduced M2 lesion development. Respiratory, that was a really obvious visual one where there's much less lung damage. Also, there was less secondary infection, reduction in viral shedding, and a faster recovery of intake. And finally, in calves, an improvement in rumen and papillae development in just normal healthy calves, and in calves that were stressed either with an enteric bacterial challenge or at weaning, there was an increase in feed intake and an improvement in fecal scores. So those were just the observations that were made. How were they happening? What was going on there? Well, again, Dr. McGill's group looking at all this research and looking at, for example, the RNA sequencing that I mentioned earlier. Let's start with immunity. Let's start with the microbiome, since that's how we led with our presentation. Supporting the microbiome. Well, we saw where it stabilized that native flora. It helped to maintain population diversity, and that really stabilized ruminal pH. Well, by really stabilizing that microbiome and keeping that rumen pH where it's supposed to be, that can lead to an improvement in digestive efficiency, more ruminal VFAs, a reduction in LPS and in lipoteichoic acid from bacteria that would be dying in that lower pH environment. Following along with the microbiome, if we do improvements there, we can have improvements in other areas related to gut health. So our observations with improvements in epithelial integrity, in papillae surface area, in intestinal villus height and in improvement in tight junction proteins were observed in terms of gut health. With immunomodulation, how could we see those effects across mastitis and respiratory and foot type problems? Well, the first thing that was observed was an increase in antimicrobial response. So the innate immune system, white blood cells, more quickly responding to that infection. When those white blood cells got there, more effective at killing that pathogen. Really interestingly, in Dr. Valetti Raboni's work from the University of Illinois, there was a 23-fold increase in CAF-L4, which is a peptide that's used to kill bacteria by the white blood cells. 23-fold increase in animals when they were on NutriTek. So increased white blood cell effectiveness. And then we also saw in the numerous studies there, less inflammation, less oxidative damage. That helps with animal recovery after this infection. As we saw in the mastitis challenge, cows coming back to their normal production, or in the BRSV lung challenge, lungs not damaged nearly as much. So really, again, really interesting. Overall, supporting metabolism to improve health and productivity of the animal. So that's kind of the journey of how we tried to take these things from what we saw in the field and wondering, were our products actually influencing them, to using challenge models and working on mechanisms of action to really prove that, yes, they really are having an influence. They really are helping that animal to be more productive, helping her immune system to better respond to infections. And with that, if you have questions after listening to this, here's my contact information. I would be happy to try to help out with those questions. Thank you very much for taking the time to listen to this little and long and lengthy but interesting journey that we've had. Thank you. Bye-bye.
Thanks for tuning in to the Dairy Knowledge Exchange. Don't forget to check our product page for featured products and promotions throughout the year. Connect with us on LinkedIn or share your thoughts and topic suggestions directly with me at pat@ddingredient.com. We look forward to hearing from you.